Hello everyone, welcome to Mathematics Pathshala. Today I will discuss a problem which come in CHR UGC NET December 2023 in real analysis in part B. Let's see the problem. Consider the following infinite series. Basically they are given two series. We have to check the series are convergent or divergent. Okay. In A, given that n summation over n equal to 1 to infinity sine n pi by 2 by root n by root over n. Now sine n pi by 2 when n is even. When n is even, n can be written as n equal to 2m. So sine n pi by 2 becomes sine 2m pi by 2, that is becomes sin m pi. Okay. Now sin m pi is what? Sin m pi is 0 for all m belongs to natural number. So when n is even, the term will vanish. Okay. When n is what? When n is what? N can be written as n equal to 2m minus 1. N can be written as n equal to 2m minus 1 where m is natural number. So sine n pi by 2 becomes sine 2m minus 1 into pi by 2. Okay. When m equal to 1, that is becomes what? Sine pi by 2. Sine pi by 2 is what? 1. When m equal to 2, that is becomes what? That is becomes sine 3 pi by 2, that is minus 1. When m equal to 3, that is becomes what? Sine 5 pi by 2, that is also 1. When m equal to 4, that is becomes what? That is becomes 7 pi by 2, that is minus 1. So 1. So when m is odd, when n is odd, sine 2m minus 1 into sine n pi by 2 becomes sine 2m minus 1 to pi by 2, that is becomes basically minus 1 to the power m minus 1. So the given series summation over n equal to 1 to infinity sine n pi by 2 by root n becomes summation over n equal to m equal to 1 to infinity sine 2m minus 1 into pi by 2 by root over 2m minus 1, because when n is even, the term will vanish. So only odd term will remain. So that is becomes m equal to 1 to infinity minus 1 to the power m minus 1 by root over 2m minus 1. So that series becomes what? That series becomes alternating series. So it can be written as summation over m equal to 1 to infinity minus 1 to the power m minus 1 into am. What is am? Am equal to 1 by root over 2m minus 1. So for the series test, we will use alternative series test. Alternating series test, that is also called Leibniz test. Okay. What is said by Leibniz test? There are given a series summation over n equal to 1 to infinity minus 1 to the power an. It is convergent if the requirement 1 is n should be monotonically decreases A should be monotonically decreases, and our requirement 2 is limit n tends to infinity, an should be 0. Okay, then the given series is convergent. Here an is what? An is 1 by root over 2n minus 1. 2n minus 1. We can see that when n equal to 1, the series is a1 becomes 1. When n equal to 2, that is becomes 1 by root 3. When n equal to 3, that becomes 1 by root 5. When n equal to 4, that becomes 1 by root 7. So the series is decreases. The series is decreasing as n tends to infinity. So, and that is monotonically increases, because 1 less than 1 by 1 greater than 1 by root 3, 1 by root 3 greater than 1 by root 5, and 1 by root 5 greater than 1 by root 7. So that is monotonically decreases. So our requirement 1 is satisfied, and we have to check the limit of an. Check n tends to infinity an equals to what? Limit 1 by root over 2n minus 1 n tends to infinity. That becomes what? 0, as n tends to infinity. So the limit of n becomes 0. So requirement 2 is also satisfied. So the given series is convergent. By what? By alternative series test we get the given series is convergent. So A is convergent. A is convergent. Okay. Let's check the option. In the option 1, what is says A is convergent? What we get? A is convergent, but B is not convergent. So we have to check B. Now in option 2, what is said? That A is not convergent. We get A is convergent. So option 2 is false. In option 3, what is said? Both A and B are convergent. So we have to check the option B, the given B series. And in fourth option, what is said? Neither A or nor B is convergent. We get A is convergent. So option 4 is false. So we have to check the option, the given series B. Okay. So in B, what is said? Summation over n equal to 1 to infinity log 1 plus 1 by n square. Okay. So before doing this series, before doing the convergence test of the series, we will recall limit comparison test. Limit comparison test. Okay. What is limit comparison test? They are given two series an, bn, such that an greater than equal to 0, bn greater than 0 for all n. Okay. And C equal to limit n tends to infinity an by bn if 0 less than C less than infinity, that is C is finite, positive finite. Okay, that is C is finite, positive finite. Then either both the series convergent or both divergent. Okay, either convergent or divergent. So let's check. Here C equal to limit. Okay, here let an equal to log 1 plus 1 by n square and bn equal to 1 by n square. Here we can see that is greater than equal to 0, that is greater than 0 for all n. Okay. Now we have to check the value of C. Limit n tends to infinity log 1 plus 1 by n square by 1 by n square. Now we can see that as n tends to infinity, that becomes log 1, that is becomes 0, as and that is also becomes 0. So that is 0 by 0 form, that is 0 by 0 form. So we can use L'Hospital rule for this. So we will get limit n tends to infinity, here we get 1 by 1 plus 1 by n square, and derivative of this we get minus 2 by n cube, and from this derivative we get minus 2 by n cube. This term is cross off, so we will get 1 by 1 plus 0 equal to 1. So C becomes 1. So this C is positive finite number. So the series AN and BN will be convergent or divergent. Both will be convergent or divergent, because C becomes positive finite number. Now here we let Bn, we let Bn equal to 1 by n square. So summation Bn equal to summation over 1 by n square. So we will use P series test now. The series 1 by n to the power p is convergent if p greater than 1. Here what is p? P equal to 2. So the series Bn will convergent, Bn will convergent. So since the C is positive finite, so by the limit comparison test we can say that the series A will convergent, because either both the series are convergent or divergent. So here we see both the series are convergent or divergent. Here we get the C is finite, positive finite, C equal to 1, and also we get the series Bn convergent, Bn convergent. So An should be convergent, so the given series will be convergent. Okay, so the given series will convergent, so that is convergent. So both the series An Bn are convergent, both the series An Bn are convergent. So in option 1 what is said that, in option 1 said that A is convergent but B is not convergent. Here what we get? B is also convergent, so option 1 is also false. But in option 3 what is said? Both A and B are convergent. Basically we get this, so option 3 is true. Thank you for watching this video. If you like this video, please share and subscribe. Thank you very much.